So here we've got a little program that I've been working on for a while. Maybe a week or so. It started off. I actually just wanted to like print out uh, a sphere of the stars. So I got some data on the locations of like navigational stars, so I could just put it in manually because there's only like 50 or so of them. And I got that working pretty well, and then I dropped in the horizon, the ecliptic, and then I was like, hey, maybe let's just align this to my calendar system. I don't have the moon in here yet, but I do have the sun. It is roughly approximated. It's off by maybe 10 or 15 minutes over the course of a day. It's pretty accurate. Um, and for convenience, actually, the location that it's using is maybe 20 or so miles from me, something like that. So it's not going to be super precise anyway, but pretty close. Down here, this part that I've been working on is basically a solar clock. Yeah, solar clock and calendar that uses my 6060 7752 system. So here, if you keep an eye on this, that'll move. Um, you can probably watch that one move. Because that is basically the minute hand. Although a minute is, on this clock, is 2 and 2/11ths of a minute. It's a little bit longer than like an SI minute. And the reason for that is the day is divided into 11 parts. And the reason for that is if we do that, then we can divide the year into 13 months of 4 weeks of 7 days exactly. And now you've got the 13 by 4 gives you 52. 7 days that are each 11 hours give you the 77. And then there's 60 minutes in your hour and 60 seconds in your minute. So it ends up aligning almost perfectly with our timekeeping and calendrical system as we have it already, mostly apart from the number of hours in the day. And 11 is actually fairly familiar because it's really close to 12, and usually when we have a clock, we're using 12 hours. So it's actually pretty fucking close. It's really fucking close to use 11 instead of 24 anyway. In a way. So basically, like each one of these hours, and you can actually see that minute hand has now moved because I had the crosshair on the little circle, and it is now moved out of the way. So what this is doing, so this is your 11 hours, and those are actually these big ticks here. And this actually progresses to the left, so this is, it's actually set up to project onto the sky instead of be like a depiction of what you see when you look up at the sky. It's flipped so that it acts like a projection. So sunset is over here. Sunrise is over here. I do have a toggle where you can flip that. I don't think everything is calibrated for that correctly. Like this in particular I don't think is set up for that. So if I flipped it, I don't think this would flip correctly. Because there's 11 of them. And this lines up on sunset on equinox. So average sunset, basically. Over here, we're right in the middle of an hour. Right. So sunrise, I figured sunset is actually the more important thing because it's moonset is the thing that we're looking at for lunar days. So sunset should be the thing that we're looking at for solar days. So this top hour is actually sunset, or your average sunset. It's not going to be sunset every day, but it's going to be sunset on equinox is when it's pretty much going to align perfectly. So then as it comes around, this is nighttime, this half, and then this half is the day. And then here, because the way the 60 is set up, we divide it into 3 groups of 20. So this marks our 3. And then our 20 is cut into 4 5s. So I'm actually using the way that it's notated. I'm actually using that directly. And then over here, we've got 4 weeks of 7 days. So the this week started 2 days ago on September 21st. It's a little bit wrong, so it's a little bit inaccurate because equinox should have been yesterday, the 22nd. But this is actually out like 1 day from that. And the reason for that is that this is actually the way this is measured. It's using like a perfect circle instead of the slightly eccentric ellipse that the Earth's orbit actually is. So I'm pretty sure that's where that error is coming from. There's also some other small approximation errors that are probably accumulating. But overall, whatever. This ends up lining up really, really well year on year, so this works really well. And so to make up for that extra day, because 52 times 7, so we've got 52 weeks of 7 days. 52 times 7 is not 365, it's 364. So what I did is every year, the summer solstice is added as an extra day. And then to get it to align pretty much with the Gregorian calendar, with a leap day, more or less every 4 years, not exactly every 4 years, we add in a leap day every 4 years on the winter solstice. That way, things end up lining up really, really nicely. The days that you drop in are actually significant. The first month, so if this were marked up here in this first month, this lines up with the first month of the lunar calendar, and it includes the summer solstice, just like the first month of the lunar calendar does. And there's 13 of them. So in a leap year, and a leap year in the lunar calendar, this is actually going to line up pretty well. Although in most years, it's going to fall out of alignment because there's 13, and most years will have 12 lunar months. So there's that. Basically, these two systems don't really talk to each other. They just coexist. But they do have some points where they line up. So like at the beginning of a lunar month, the solar day and the lunar day start at the same time. And at the beginning of a year, they're going to line up pretty closely within a few weeks. Right, because the furthest out, the earliest that the first lunar month could start would be over here somewhere. And the latest it could start would be over here. So you have just shy of a month's range, pretty much a month, that it can walk around. I thought that was kind of interesting. I don't have a second hand yet. I don't know if I will. I don't know if I'll do that or not. But it would, sort of like how a conventional clock operates. It could just, because it's 60 seconds in a minute and 60 minutes in an hour, The second hand can just live in here, like on a conventional clock. But the 11 is in no way compatible with this system of 3/4s. So it sort of needs its own, right? 11 and 60 are coprime. Largely because 11 is prime. Also, like 4 or 28 and 13 are coprime, so they get their own dials, basically, but on the same device. So here we're looking at days, weeks, months, year. Here we're looking at minutes, hours to the day. So as this guy goes all the way around, this should click from one to the next. And this hand is actually, it's the only one that is actually set to an integer. So it'll actually just click over when it goes. All the other ones move continuously. So now, pretty much got a little bit of fine tuning on the solar position, and I guess drop in the lunar clock over here, the lunar calendar system over here, and it should be pretty nice.